Okay, let's talk about some violations to the octet rule. There are some covalent compounds of beryllium that we're going to have to consider. Some covalent compounds of group 3A elements, in particular boron, that we'll consider. There are some substances that have an odd number of electrons, but that's a minor point for right now. The broadest group of exceptions will be 4, where they have to have more than 8 valence electrons to accommodate all the substituents. And so there's a bigger set, and that's the one we'll focus on. There are some compounds of the DNF transition metals. You may talk a little bit about that in Chem 111 or the next course, but we're not going to focus on that here. So in the cases where the octet rule doesn't apply, you can have some that have fewer than 8, rules 1, 2, and 3, and more than 8, which is 4 and 5. So what we want to do is we want to look at a few substances that have too few electrons, in our case the beryllium and the boron, and then a couple that have too many, the sulfur hexafluoride and the xenon tetrafluoride. Okay, let's look at BeH2. So we got Be. There's one of those. Now beryllium is in group 2, so there's 2 valence electrons for a total of 2. Hydrogen, there are 2 of those. It's in group 1, so 1 valence electron for a total of 2. That gives us 4. That should tell us right away, not going to obey the octet rule, but let's go ahead and work it out. Be. We're going to draw a bond to hydrogen, a bond to hydrogen. 2 bonds, that's 4 electrons, and I'm out of electrons. And so I have no choice in this case but to violate the octet rule. But beryllium compounds tend to be good with 2 bonds or 4 electrons, no non-bonding pairs, and tend to be happy with that. So that is a good structure. Now what if I had boron trifluoride, BF3? Boron, there's 1 of those times 3 valence electrons for a total of 3. Fluorine, there are 3 of those. It's in group 7, so 7 valence electrons, 21, to give us 24 valence electrons. So if I go boron, we're going to go fluorine to all the sides. That's 6 valence electrons. That's going to bring us to 18. Each of the fluorines needs 6. 6 times 3 is 18. Resist the urge to add a double bond. In this case, boron is going to be perfectly happy with 3 bonds or 6 electrons. So we're just going to add the non-bonding electrons to fluorine and use up all of our electrons. And boron will be perfectly happy that way, and that's a good structure for that compound. Now SF6 should screen violation because it's got 6 substituents. I'm going to have more than 8 electrons to account for all that. But let's go ahead and add up the valence electrons. Sulfur, there's 1 of those. It's in group 6 right under oxygen, so 6 valence electrons, total of 6. Fluorine, there are 6 fluorines times 7 valence electrons because it's in group 7. And that's going to give us 42, which will give us 48 total valence electrons. So now we're going to draw our sulfur in the middle, fluorines in all directions. Fluorine, 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 and fluorine. So that's going to take away 6 bonds. 6 times 2 is 12. So we're going to take away 12. That's going to give us 36. Sulfur already has too many, so let's focus on the fluorines. Each one needs 6. 6 times 6 is 36. So all we really have to do is fill in the non-bonding electrons. And that would be a completed structure for the sulfur hexafluoride. Now let's talk about the xenon tetrafluoride, XeF4. Again, it should scream violation. It's got a noble gas in it, so it's going to end up with more than 8 electrons for sure. Xe, 1 of those is a noble gas, so 8 valence electrons for a total of 8. Fluorine, there's 4 of those times 7 again. 28. They'll give me 36. So we're going to put xenon in the middle, fluorine to the sides. And that's going to take away my 8 and put me back at 28. Let's ignore the xenon for right now. I got 4 fluorines, each needing 6 electrons. 6 times 4 is 24. So I could add in the non-bonding electrons on each fluorine, and I have plenty of electrons to do that, even too many. But let's figure out what to do with those in a second. So that's going to take away 24. It's going to leave me with 4 left. So now it's kind of like you put something together from a kit and you got a couple extra screws left, right? What do you do with those 4 electrons left over? Remember that last rule told us to add the electrons to the central atom, even if it made it violate the octet rule. So we're going to add 2 non-bonding pairs to the xenon and finish that structure off, and xenon does violate the octet rule.